Today, we are diving into the story behind DeepSeek-V3.2. This is an open-weight model that kinda out of nowhere started competing with the absolute giants of the industry. So the big question is, how on earth did they do it?
So what was the big deal? Why did everyone in the AI community just suddenly stop and pay attention to DeepSeek? Well, like a lot of things in this space, it all comes down to the numbers.
And this is what's just wild. You're looking at DeepSeek-V3.2, an open-weight model that anyone can get their hands on, and it's performing right up there with the closed proprietary flagships. We're talking about the big guns from places like OpenAI and Google. It's not just playing in the same league. It's a real contender.
I mean, this kind of performance is frankly shocking for an open model. And it immediately makes you ask, what is going on under the hood? What's the secret sauce here?
To really get it, we can't just look at V3.2 by itself. No, we've got to rewind a little bit and look at the groundwork, the foundational tech they built for its predecessors. And it all started with a simple focus on efficiency.
All right, the first piece of this puzzle is something called Multi-Head Latent Attention, or MLA. It's a really clever memory-saving trick, and it's all about making these enormous models way more practical to actually run.
You know, the easiest way to think about MLA is, well, it's basically like zipping a file on your computer. Before the model saves important info to its short-term memory, that's the KV cache, it compresses it way down. This saves a ton of space, and then the model just unzips it when it needs it. It's a simple idea, right? But it has a huge impact on efficiency.
So they had efficiency down, but next up, they had to tackle reasoning. For this, they developed a pretty novel training method called RLVR. And the goal here wasn't just to make the model sound smart, but to teach it to be provably, verifiably correct.
Now, this is a huge departure from how most models get trained. See, instead of relying on some subjective reward model that's just trying to guess what a human would like, RLVR uses hard tools like a calculator or a code compiler. The reward is simple. Did you get the math problem right? Yes or no? Did the code actually run? It's a clear, black and white signal that grounds the model's learning in objective fact.
Okay, with that foundation of efficiency and correctness in place, the next big challenge was context. I mean, how do you get a model to handle incredibly long texts without just getting totally bogged down? The answer was to make its attention mechanism a whole lot smarter.
And this led them to create something called DeepSeek Sparse Attention, or DSA. The core idea here is really intuitive. When a model is writing a new word, it doesn't need to look back at every single word that came before it. It just needs to zero in on the parts that actually matter.
And the process for how it does this is just fascinating. First, you have an indexer that quickly scans all the previous words and gives them each a relevance score. Then a selector comes in and just picks the highest scoring ones, say the top 2,000 or so. And only then, finally, does the model perform its heavy-duty attention calculation on just that small, hand-picked subset. It's kind of like giving the model a really smart set of highlighters.
And the impact of this is just huge. It's a total game changer for processing long documents. The computational cost doesn't explode anymore. As the text gets longer, it scales nice and linearly. That makes it so much faster and cheaper to work with these massive contexts.
All right, the final piece of this puzzle, and this might be the most fascinating part of the whole story. It came from a specialized math model, and it's all about moving beyond just getting the right answer to making sure the reasoning itself is rock solid.
The DeepSeek team themselves put it perfectly with this quote. With their earlier RLVR method, a model could just get lucky, right? It could stumble on the correct answer to a math problem and get rewarded, even if its step-by-step logic was complete nonsense. And they knew they had to fix that.
So their solution was self-verification. And with this, the whole focus shifts. It's not about rewarding the final answer anymore. It's about rewarding the process. It's no longer good enough to be right. The model has to be right for the right reasons.
To do this, they built what's basically a student-teacher dynamic right inside the model itself. It's wild. One part, the generator, is like the student trying to solve the problem. Then another part, the verifier, acts like a super strict teacher, scoring the quality of the reasoning based on a clear rubric. The generator then takes that feedback and refines its own work, getting smarter every single time.
And the incredible thing is, it absolutely works. This chart shows it plain as day. The more times the model is allowed to go through this self-refinement loop, critiquing and improving its own work, the more accurate its final answer becomes. Turns out practice really does make perfect.
So, let's put all of these building blocks together now. DeepSeek V3.2 is really the culmination of this whole journey. It takes all of these clever solutions and synthesizes them into one cohesive and just incredibly powerful model. So here it is, the full recipe. You start with MLA for memory efficiency, add in DSA for incredible speed on long texts, then you layer on that 1-2 punch of RLVR for objective correctness and self-verification to make sure the logic is rigorous.
And here's the payoff. This is what all that innovation really gets you. By combining these architectural changes, especially that sparse attention, the model can be up to 8 times faster when it's dealing with long documents. That is a massive performance gain.
So I think the key thing to take away from all this is that DeepSeek V3.2 didn't just appear out of thin air. Its power comes from that methodical journey we just walked through, a series of very targeted innovations, each one designed to solve a specific problem, from efficiency to correctness to reasoning.
And all of this leaves us with a really fascinating question to think about. We've just seen how a small, dedicated team can build a model that goes toe-to-toe with the billion-dollar giants, and they shared their methods openly. When innovation in the open moves this fast, it really makes you wonder how the entire AI landscape is about to change. Thanks for joining me.